Dear colleagues, the title of our talk on the expanding graphs of large girths and algorithms of key establishment. Authors are V.Ustimenko and T.Chojecki, UMCS, Poland. Communication theory widely uses finite commutation rings and tuples P1, P2, Pn, where Pi belong to ring K. Popular rings are modular arithmetics Z 256, finite field F to 256, because of order coincides with the size of binary alphabet. Okay, so families of ZP for prime P and ZPQ for pair of prime numbers PQ are used in RSA. Nowadays, those two algorithms are breaking by Peter Shor with the use of quantum computer. So in post-quantum computing, we need new algorithms. Okay. So our paper is dedicated to creation of new protocols for the key establishment with the resistance to adversarial attack with the use of quantum computations. We construct new platform for the implementation of protocols of non-commutative cryptography in terms of symbolic computation. So we use a fine Cremona semigroup of all endomorphism of polynomial ring K x1, x2, xn over the finite field Fp. It acts naturally on the vector space Fqn as semigroup of polynomial transformation. So the transformation looks like that, and it acts naturally on the vector space Fqn. The computation of the compositions in this semigroup is very costly because of the product of two elements of kind R, of degree R and S will have degree Rs, so degree is very fastly growing. So we use the result of interpretation of Q-regular forests in terms of infinite system of equations over the finite Q in that paper. So actually action working on this tree, this forest, induce the semigroup G and Q, which is in fact a group of cubic transformation of finite field. If the reimage of the element is known, then the computation of the product is very, very fast. So let's G and Q be such subgroup. So the protocol is the following. Alice and Bob has two elements, G and H, and they both know H minus 1 from this semigroup, and they select some vector V, P1, P2, Pn from the open channel. Alice takes positive integers k, a, and ri and forms standard form of element like that and sends the standard form to Bob. Bob takes kb and rb, forms this element gb, send it to Bob. So they exchange these elements, and after Alice compute element x accordingly this formula, and Bob used this formula to compute the same x. So they have collision element x, and they compute the value of x on selected v, and this u is used as the password. We prove that computation can be done in time O(n) square, so it's fast algorithm. So the computer experiments measure the number of cubic monomial terms in our map. So we have their stabilization. So the adversary could not get any information about the parameters Ka, Ra, Kb, and Rb from this information. Thank you very much for your attention.